We want to graph the equation 3x plus 4y equals 8 by first algebraically solving the equation for the slope-intercept form. Solving the equation 3x plus 4y equals 8 for slope-intercept form is another way to say that we want to solve this equation for y. To solve it for y, I need to first cancel the term 3x on the left side of the equation. We will do that by subtracting 3x from both sides of the equation. This will simplify down to 4y equals negative 3x plus 8. As a final step in solving 4y equals negative 3x plus 8 for y is that we need to divide both sides of the equation by 4. When we simplify the fact that we divided both sides of the equation by 4, the left side will reduce down to a y, and we'll need to remember to distribute the division by 4 into both the negative 3x and the 8. So negative 3x divided by 4 is a negative 3/4 x, and 8 divided by 4 is a positive 2. So we now have the equation in slope-intercept form. We now need to graph it. Our first step in graphing this equation is to properly set up the axes. We'll begin by drawing both the x and the y-axis using a ruler. We will then put arrows on at least the positive ends of the two axes, label the x-axis and the y-axis appropriately, and then decide on a scale to use. In this particular example, I will go with a scale of 1, 2, 3 on the x-axis, as well as 1, 2, 3 on the y-axis. Now that the axes are set up, we can begin to graph our equation. When graphing slope-intercept form, we again start with the y-intercept, and remember that the plus 2 at the end of the equation is really telling us we have the point 0, 2 on our graph. The negative 3/4 as a slope we can treat in one of two ways. We can treat this as a negative 3 divided by 4, and a slope of negative 3 over 4 means we need to go down 3 and to the right 4 from our y-intercept. So counting from the y-intercept, down 1, 2, 3, to the right 1, 2, 3, 4, puts us at the point 4, negative 1. Ideally, we want to have 3 points on our graph, and if we were to continue down 3 and to the right 4 from this new point, we'd be off the graph. So we can go back to the original y-intercept and remember that a negative number could have resulted from dividing a negative by a positive, or an opposite, dividing a positive by a negative. So we could also treat the slope of negative 3/4 as 3 over negative 4. The 3 in the numerator would then mean up 3, and a negative 4 in the denominator would mean left 4. So if we go back to the y-intercept and now count up 1, 2, 3 and to the left 1, 2, 3, 4, we obtain a third point on our line. Now that we have 3 points that do line up nicely, we'll grab our ruler again and graph the line itself. Once we have drawn the line using a ruler, we'll then add the arrows at both ends of the line to again indicate, just like with the axes, this line continues both directions forever.